Algebra 1, Chapter 4, Section 6. This will be the final section in this chapter. We're looking at arithmetic sequences. And so these are, let's say, for example, even numbers, 2, 4, 6, 8, 10, 12. We know that there is a sequence and it goes up by 2 each time. Some of them are a little more difficult than others. However, what we're going to focus mostly on is finding the nth term. And what does that mean? Well, nth term is just, let me get this here. The nth term. That means if I have a certain sequence, can I find the 20th term? Can I find the 89th term? Can I find the 35th term? It's real simple. If I have something like this, I go 3, 6, 12. Let's see, what would my next one be? What do I want to do? If I did something like that, and I ask you to find maybe the next 3 terms. So what we're doing here is from here to here, we're going up 3. From here to here, we go up 6. From here to here, we go up 12. And so what we're doing is doubling each time. So the next one is going to be up 24. And then the next one's going to be up 48. So that's going to be 48. And then 96. And we could keep going on that. So we can find the 4th, 5th, 6th, 7th term. But if I went with some numbers, let's say, let's say 14, this is one that's in the book. Let's go 14, 11, 8, and then 5. And that just goes on forever. What if we wanted to find the equation for finding the nth term, which is an equation I could use to find any. I could find the 20th, I could find the 50th, I could find the 37th. If I wanted to find the nth term in this equation, then that formula looks like this. Okay, it's going to be a to the n, which that represents our nth term, equals a to the 1, or a sub 1. That's going to be representative of our first term. In this case, that's our 14. Then we're going to add to that n minus 1, and we're going to multiply that times d. Okay, so let me put a little ledger over here. A to the n, that's the term we're trying to find. A to the 1, or a sub 1, that's our first term of the sequence. N is the number of the term we're trying to find. Here in just a second, we're going to find the 50th term, so we'll put 50 in for that. 1, or the minus 1, just stays the minus 1. And then the d is the common difference. I know that's a subtraction term, but it could be a positive or a negative number. In this case, we know that they're getting smaller, and so that will be a subtraction. So let's plug in what we have. I don't want to find the 50th term yet. I just want a formula where I can find that term. So that's going to be a sub 1, which is 14, plus, I don't know what my term is going to be because I could let it be anything. And then my difference in this case, because I go from 14 to 11, 11 to 8, 8 to 5, my difference is negative 3. I'm going down 3 each time. So now let's just use algebra skills here. Can't do anything with this 14 yet. Okay, I can distribute this. And so I'm going to have negative 3 times n. So that's going to be negative 3n. And then negative 3 times negative 1, that's going to be positive 3. So now this ends up being 14 minus 3n, because plus a minus is a minus, plus 3. And I can put that together to be 17 minus 3n. So that's my equation to find out any number. Okay, so now if I wanted to find the 50th term, then everywhere I see an n in my formula, I'm going to put in 50. And this is for the 50th, I'll write this out there, 50th term. Okay, so that's going to be 17 minus 150. And so that's going to equal negative 133. Now again, if you wanted to find 50 terms and you wanted to go out and just do that 50 times, you are more than welcome to do that. But this makes it just a little bit easier. Now, what if I wanted to find the 242nd term? So that's going to be, fill that in there, 242nd term. So that's going to be 17 minus 3 times 242. So that's going to be 17 minus 726. And so 17 minus 726 gives me a total of negative 709. Okay, so just a review. Nth term equals first term plus n minus 1 times the difference. Again, difference could be positive or negative. And that should take us through the end of Chapter 4. This is 4-6, Arithmetic Sequences.